Hello, I'm Philip Meyer. Welcome to my video blog. In this video we will have a look at the Coherent Innova i70 laser again. I will show you how I set up the water cooling circuit and get that up and running properly. So this is the water connector for the Coherent Innova i70 power supply. We have here the water inlet. And this labeled drain, that's where the used water comes out. And these two I taped it to protect dust from entering here. That's where the laser head is connected. And unfortunately these two are American style threads. I was at the hardware store and asked around people, but nobody knows which type of thread it actually is. We have the European, in Europe we have something different. Yes, this is the adapter piece for that. It came with my power supply. Unfortunately for that I don't have anything to adapt, but at least here I have this thingy here, and you can see on the left side we have the American style thread, and this is the European side, so this goes then into here. So this goes on top of this, and then you can connect the regular water hose. So these things are pretty standard here, even if they are not widely used. People like to use this Gardena stuff, which is okay, I think, but right here you shouldn't use it because Gardena sometimes tends to leak a bit. I mean, it's for garden work and stuff. It's not made to be super tight, and you've got all the electronics and high power stuff. So here we need something that is really it doesn't leak. On the internet I found at least this. This is my original idea was to have Gardena right here, but as I said, it's not a good idea to have it right here. So this fits. This is an US style Gardena adapter. Anyway, I don't need that anymore. So for the water inlet I have everything I need, so that's fine. Just need to screw it here, but for that I have nothing. And and I was also not able to get the proper pieces, so I have to hack this. Let me show what I got at the hardware store yesterday. This is my stuff from the hardware store. I have a 10-meter water hose. So that should result into two 5 meters Gardena to whatever this is called adapter pieces. So that's the opposite piece, and this is how the coupling looks like. So this is the piece that should go on top here, even if it doesn't really fit. It's only for one turn, but of course these inside of this we have of course a European thread. My idea is to screw it down anyway, and either I will grind away enough of these threads that I have at least one turn left over, and I can get these piece deep enough to touch the washer here. So that's important. I have to have it sealing up. And in case of this fails, I can also always solder it. Show you what's my idea is here. These things, I think this actually not too much, but this is screwed down on top of another thread, so this should come off. Should be able to take it off, and once I have it off, I can do whatever I like with it. I can solder it, and then when I'm done with my work, I can put it back on. So let's try to work on this. Let's try to get it off first. So I have my wrench here, and I'm gonna try to get this off. that works. Yeah. So let's see. Yeah. This wasn't a problem, so now it's off and you can have a closer look. This goes aside for a moment. And here we have it. So this needs to connect to that piece, and it has to be connected in a way that it doesn't leak. So I don't know if that's very visible, but right now the brass of these end piece here doesn't touch the washer here, so I need to get it down enough to make it seal up properly. So as you can see, I grinded that down now with the Dremel tool with this head. That works very well on brass, even if it's made out of kind of sandpaper. So this now goes, if you see that, now slides smoothly into it, and then I can screw it down with the very last two turns. And if you look into it, I think we are close enough to seal it up. So let's try to put the washer back in and see how that works. Here it is, and looks like the washer is sealing up quite well. Yeah, I also blew into it, and it I'm sure it's tight. It looks to me that this is now waterproof, and I can attach this back to the laser. And the good thing about this, I do not have to make any changes to the laser's original state. Of course, I want to preserve it like it is, because it's now vintage piece of hardware, collector's item, so to say. So of course I want to preserve the original state. So back to the drain thingy here. This is basically going onto it like so, and I've cleaned it a little bit because it had these white stuff you see that's still there, and it's not 100% clean, but most of it is gone. There was some material in there to make it sealed up properly. I will seal it again using this Teflon tape here. So yeah, obviously I can't do that with one hand, so I'll do it now and show you the result. So it's now again very tight top of here, so I will now mount the other pieces. So looks good to me. Now we need to make the the adapter pieces to adapt that to Gardena. So the hoses are now finished. Here we have the end that goes into the laser, and here's the Gardena end. I plan to reuse the existing hoses we already have in our house. These are basically just only adapter pieces. I mean, they are only 5 meters long. So this goes into the laser like so, and it's hopefully then a waterproof interconnect. And now it's time to try this out. I will wire the water supply up and see if it's waterproof, and see if there are any leakages, and let it basically run for a while just to see if everything is fine. And then we should be ready to go into a first smoke test with this unit. So that's my setup right now. I will explain really quick. So here in the back we have the laser head connected to the power supply here, and this is the connector for the current control, for the current. That's where the current is flowing through, and here we have the connector for the instrumentation. There are two separate connectors. Of course, I didn't connect the power yet. I only want to examine the correct function of the water circuit, so that's all I want to do for now. And especially if you are new to the topic, you should first experiment a bit with the water, so you will make it wet anyway, so in order to prevent electrical damage. So I just didn't connect it to power at all right now, so if I make any circuits wet here, it will not be harmful. So this is the connection of the laser head. So this is where the water is going to the laser, and here's where it's coming back. And when it's coming back, it will pass this thingy here. So that's a flow switch. It detects if water is flowing, and then it runs out. When it has passed the flow switch, it runs out to here to the tap again. Yeah, one word to the flow switch. Sometimes these things apparently tend to hang. In my case, it doesn't hang, but in some case it can, and then you will have flowing water, but your laser power supply is unable to detect that water is flowing properly. In this case, I've read on internet forums, you should connect, basically exchange that connector with that, so twist them, and then try running water through for a short amount of time, and then of course change it back and see if it works again. So that might makes the flow switch function again. In my case, I don't expect any problems. So yeah, I've removed the plate here to have better access to that, to see if that somehow leaks. I mean, behind there's also possible risk for leakage, but yeah, unfortunately that cannot be taken out very easily. Yeah, so but removing the plate is easy, so I did that. Yeah, I think we just turn the water supply on and see what happens. So there's still air in the system. Here you can see the flow switch doing its job very properly. Yeah, and I think we'll let that run for a while just to see if there are any leakage. And by the way, the pump noise you hear is a pump that pumps the water up, because our house is below the wastewater line, and yeah, so you have to pump up the water here. So that's a bit annoying, but yeah, what can you do? Yeah, and we can already see, unfortunately, the drain from the laser head is a bit leaky, so there's a very tiny bit of leakage, but I think that's not too much of a problem. I will just for the first test, I will just put something here, and then it should be okay. And let's see here. Looks okay to me. Now let's try the test. That's okay. No leakage. Yeah, this apparently also does its job very well. Yeah, this is also okay. So from the outside connectors, I think this is the only one that's a bit leaky. So I think that can be easily fixed with some Teflon tape. So I think it's fixable. So here we are on the laser head now. It's a bit more difficult to see if that causes problems, but that's okay, I think. There's no leakage whatsoever in this connector. And here as well, that's fine. By the way, interesting to note, these are the same connectors you find on the outside of the power supply. So there's this little button, if you press it, it would come loose, but yeah, I don't dare to press it. So let's see what's here. We also have some. Yeah, that's okay. No problem here. So let's see what we've got here. Nothing, that's good. That's also good. Yeah, very nice. No leaks here. Yeah, just a quick recap on what we are looking here at. This is how the transistors of the current regulator. That's basically a linear regulated current controller. Yeah, it's pretty inefficient, and it also needs to be water cooled, so the water running into here from the supply first passes the these regulator bar here, which is also called, these things are also called pass bank, so it's a pass bank, and then runs into the laser, comes back, and yeah, then it's here. Here we have the three-phase rectifier, so here there's three phases coming from the power supply. They get rectified, and that fuels the laser head basically after it passes through the current regulator. And yeah, of course you need a stable current to drive an argon laser head. So I try to check here as well, which is way more difficult. But looks good. I mean, it's not wet or anything. Yeah. So maybe you can try to check here as well. Yeah, looks good to me. It's dry. If I touch that, I can really feel it's cold. It's really cold. So I think it's now time to turn it off. We have wasted enough water here for this test. There's the excess water dropping out of here. Yeah, by the way, there's one more thing I wanted to show you. So this is a water filter. So we have a centralized water filtering facility, so to say, in that house. So that's the reason why I didn't attach another one. So normally, if you're not sure about your water supply, you should add a filter like this to be right before your laser. But currently I rely on that one, and apparently I think the water here is pretty clean, so there are no particles in there. And yeah, what it just does is it just filters the water coming into entering the house, and so that's how you get clean water and without small particles, because sometimes there may be small particles in your water supply, and of course if that enters the laser head, I think it will not damage immediately, but it can be a problem. So yeah, so if you're not 100% sure about your water supply, yeah, please add a filter in series. Yeah, and there's even one more thing you should check on your laser power supply. You find a note about the water consumption, and in my case it says 7.7 liters per minute. So that is something you should check. I mean, we have 4 bar water pressure here. That's really sufficient, so shouldn't be a problem, but I will check it anyway. I will just check how how many water I get out per minute. And in order to do that, I will just stop the time it takes to get 7.7 liters into this can here, and I will just see if I'm in the ballpark or not. Okay, let's go. Okay, I think I have to turn it off now. Oh, 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 oh. Wrong direction, but in time. So, yeah, including all the latency to turn it off and on again, I think we are pretty well in the ballpark. So it took less than a minute to fill this can entirely with water, so that's definitely more than 7.7 liters per minute. It's around 10, so that's fine. Yeah, and as I said, it shouldn't be a problem in the normal case, but yeah, let's say if you are living in a large building at a and your flat is at a very high floor, you might get a little less water pressure, and then you might be a problem for you to run the laser in your flat. But here it's definitely not a problem. So well, I think our work is done here. I will now put the plates and covers back in place, and then we'll set up this thing properly in the laboratory and connect it somewhere properly before we move on, of course. So I hope you enjoyed my video. Catch you next time. Bye bye.